we did 4 and then 5 is the next
Now at 5 milliliters of distilled water to mixture, explain why any new change in terms of the... Okay. Okay, so if you add it, the solution will become dilute enough that the color may be hard to see. I guess I don't explain any new change in terms of the Chatlier principle. I would ask Brother Hay with that one. Because everything that... I know what you're talking about, where you go to the less mole side. Right. No, you go to the more moles.
Mm-hmm.
So what do you have? What is this one?
What's happening?
What is the...
Copper nitrate. So Cu parentheses NO3 and then a 2 after it, and then HCl. So equal concentrations.
What does it make?
Okay, this is the question. So on here it gives us the equation as CuH2O4 plus Cl minus.
Sorry, and those are there's an entire given equation. You can, I guess, erase the top one.
So the bottom one is like the one that they give us.
Which is what?
CuH2O4. And then with the 2 plus. And then plus 4Cl.
4Cl?
Yeah. 4 chloride equals copper chloride. Yes. So plus it
Gives you copper chloride.
yes. Cl4.
CO4.
Yeah, and then plus 4H2O.
Plus 4H2O?
Yes.
Okay. Okay. And now we're saying we added more water.
So
Says you add 5 milliliters of distilled water to the mixture. So what happens is you're adding copper nitrate to hydrochloric acid, but it comes out with
Okay,
an
so
equation
which
like that.
way would it shift?
It would shift to the...
So if you add water,
if you add water, it's going to shift left.
this way, right?
Yeah. Is that, so is that because we see water over here? So it doesn't have to do with the side with more moles?
Because, okay, so what I'm looking at is this is at equilibrium, right?
Okay.
If we put if we give this water to mix with, it's going to mix and go here.
Right.
So how do you explain the color change? It just goes clear. Did yours give you color though?
No, I
Tried to
was
see
saying
one.
I didn't actually look, but I imagine it would have been a faint blue,
I wonder.
but it was largely.
Wait, so what happened in the experiment? So, okay, you had
So originally it went
this.
from blue to green,
blue to green,
and then you add water and it turns clear.
but with a light, with like a faint blue.
I would assume neither of us paid that close attention.
That would make sense.
Okay.
Because, okay, so this was blue, right?
Right.
What you started with.
Okay.
And when you ran the experiment, it went green, right?
Yeah.
But you had more water, and it went back blue.
Okay.
So the reason that, if you look at this too, 1, 4, 5, 1, 4, 5. So that doesn't help you really with which one has more moles. For like volume.
Right.
But it does make sense that if we had water here,
Then it would
we're
go
going to
that
push
way.
this way.
Right.
So it would shift to the left.
Which, I mean, hopefully it was a faint blue color.
Yeah, I'm not sure. I just remember it being clear. I don't remember.
Are you guys just saying you think it was this? Cause
Well, that, yeah, I assume from
just
the
like
purpose of it was to
go back.
learn that, yeah.
Okay. Yeah. So what you're thinking of with the space is like if we run an experiment in here, and then we like let it happen in here, because we do the experiment in this bigger one. But then you're dealing with like gases as well
Okay.
and stuff like that.
So typically, the Chatlier is
Your idea is
principled-
right. If this would have been like just this over here, let's say we didn't have the water.
The
Something
water
like that.
shoots to the right.
Yeah, but then the reason it's weird is because you have water. So if you're shrinking the volume of, I don't know how you shrink the volume of water, like it would shoot out of your container,
Right.
I would think. But I guess if you somehow can push it together,
Right.
it would want to go. Well, it would want to go this way. If you make it bigger, your container. Would that be?
We want to go that way.
You're usually doing it with gas, or I guess gas in water,
Okay.
not really just like.
Right. Right.
Yeah.